Let's factor question number 13. Let's pay attention to the fact that these look similar. These are like fraternal twins. So by pulling out the -1, we can make them look the same. So let's do that. So we have x squared, x minus 2. Instead of plus, we'll pull out a -1. And so we get x minus 2, because when you feed a dog, feed the cat, we get the same result, times 9. So what we have here is now we have common factor, the common factor being x minus 2. So let's continue this up here. We're going to pull out a x minus 2, and let's use distribution. This x minus 2 times x squared becomes the first term. And the second term, we're going to multiply by -9, because x minus 2 times -9 becomes this part over here. The -9 makes the term negative. You see a negative sign here. And then we have x minus 2 over here, just simply being multiplied. Alright, so this is factored, but we can factor further. X squared minus 9 is difference of squares. So we go plus 3 and minus 3. And there we have it, fully factored. Let's try question 14. If you look at it carefully, if you just squint your eyes a bit, you can see how this here is a trinomial. So we can let this ugly inside be a. Let a equals 3x plus 2. Then this question becomes factor 2a squared plus 9a minus 5. And this is simply trinomial factoring, where the coefficient is not 1. You can try using the rainbow method, or you can even try guess and check. We know that 2a times a becomes the first part, and we keep on trying all the possibilities of 5. 1 times 5 is the only possibility, so let's see if we can get lucky here. Let's try 5 and 1. 2 times 5 is 10, and we want to make that a positive, and let's try negative here. Minus 1a becomes a 9a. These multiply to be -5, and 2a times 5 is 10a, minus a is 9a, and they add to be positive 9. So we factored successfully dealing with a, but we know that the original question was speaking the language of x. So let's convert it back by substituting x, 3x plus 2, back into these a's. So let's use big strong brackets here. This is going to be 2 times something minus 1, and the a is replaced with a bracket plus 5. And a was 3x plus 2. So 3x plus 2, we're just substituting. And there we have it. We can use distribution here. This is going to be 2 times 3x is 6x. And this is going to be 2 times 2 is 4. 4 minus 1 is positive 3. This is 3x. 5 plus 5 is positive 10. And remember that you can continue to factor. Keep on going. You can even pull out a 3 here. Let's pull out a 3 out of this factor over here. So this is 3, bracket, 2x plus 1, 3x plus 10. And now we've fully factored. Let's try question 15. We notice the same repetitive inside here, so we can let that be a. Let a equals x squared minus 1. So the original question now becomes, can you factor a squared minus 7a plus 12? And this is simple trinomial factoring. This is a. The minus plus pattern means it has to be minus minus, because something times something is 12. It adds to be -7. Let's try 4 and 3. Yes, 4 times 3 is 12. And when you subtract them, -4 minus 3 indeed is -7. So this is factored. Now remember that we are to substitute for x squared minus 1 into a. So we're going to substitute into here and here. Let's use big strong brackets. And we're going to replace a with x squared minus 1. And we have a -4 here. If you really want to put some brackets, you can. And then we have a minus 3. A minus 3. And a happens to be x squared minus 1. So let's keep going. We have x squared minus 5. Minus 1 minus 4 is -5. X squared minus 4. And be careful, you can factor even further. So this one is done. We don't want to deal with plus minus root 5, which you could, but we just like integers, so we're going to leave it as that. But this one here, we can keep on going. This is the difference of squares. Plus 2 and then minus 2. So if you want to verify your result on wolframalpha.com, you can do so, and you can see the result here is equivalent to what we have here. Now it's your turn.